And by the way, just make sure you copy the Rhino file from Dropbox, not move it, because it seems like one of you might have just removed it.
The tutorial file is like .rhl, not .bbm.
Yeah, someone took it out of the
Yeah,
Dropbox.
that's what I'm saying. That I think someone just dragged it over. So can you?
I'll put it in again because. Someone's uploading it. I don't know.
Let's see.
So it's being uploaded right now. I don't know. Someone took it out and put it back in. So it'll be there in a sec, hopefully. But for now, you can just watch. So what I did was I kind of gave a thickness to this. So when we revolve that, you'll have a thickness to the vase, and you can see it kind of starts to look good. Right now, we don't have a base to it, so what we can do is, in the front viewport, you can see we have these two lines. So what you want to do is just finish off your vase. So we're going to draw two lines here, and you can see we only want these lines to go to the middle because they're going to revolve around the center. So we just need to trim these. And here, so what you want to do is join all of these together. And maybe give a little fillet to this outside one so it touches the ground nicely. And this one too. So now we have this complete one, and we can revolve this around the center, and you have a finished vase that's nice and touches the ground. So the next revolve command we can use is rail revolve. So that you can make any kind of shape that goes in 360 degrees, and it will revolve a curve around that. So the command is rail revolve, and it'll ask you for your profile curve. So that's this curve, and then it'll ask for your rail curve, which is kind of the defining curve. And then it'll ask for your axis. And so asking for your axis, it wants to know the middle of the object. So what you can use is you can use Smart Track, the feature that we talked about in the first lecture. And what it does is, if I want to find the middle of this object, I can find the midpoint here and the midpoint up here, and its midpoint in the other axis. And so when I go to the middle, it'll say, show me the intersection, and that's the middle of the object. And then I can draw it up. And then it will revolve that, and you can build your curve similar to the regular revolve command, but you can go around a square shape or a rounded shape. I also got an email this week about construction curves or reference curves, and using those. I think mostly they're from SketchUp, and the ability to kind of just draw curves and be able to work from them. Rhino doesn't explicitly have that exact same command. I think the best way to do that, if you want a reference curve, is just to draw in the curve and work from that, and then use the offset command. So if you wanted a reference curve, you could just draw a line, and you could draw it at any distance, and then offset it either way to kind of create references off of that, and maybe put it on a different layer, and then you can hide it and show it and use that as a reference. We'll kind of go over drawing lines in 2D to help with exploded drawings. So the final, or one more thing we're going to look at before we look at make 2D is we're gonna just do a rough outline of this vase that I have. So I just want to hide everything else for a sec. And over here in the reference file in 5, I added another list of useful commands that you can kind of reference if you're working through your projects. So I kind of lost everything over here, so I can use the zoom selected command to find everything again. So this vase is kind of built up of this ribbed layer on the top, and then it flows into this. So the easiest way to do this is to make this as one object, and then make this as one object, and then Boolean them together, join them together. So in the top viewport, I've kind of drawn these lines as reference lines for everyone to use. And then down here, I've drawn kind of a representation of what this curve is going to look like. So I just want to hide this so it's easier for you guys to see. So what we want is to get this repeated all the way around the outside. So the easiest way to do that is find out how big this object is. So we can use the distance command and figure out that this little nub is 4.56 millimeters wide. And we're going to use a command, I don't think we've done it yet, it's called array curve. And so that's going to array this object all the way around this curve, so we can select the object we want to array and enter, and then the path curve is this. So it's going to, this little box is going to come up. So when you're doing this, there's two options. You can either define the number of items you want there to be on the curve, or you can define how far you want them to be apart. So for us, we want them to be a specific distance apart. And these objects you should play around with. No rotation makes it so this little nub isn't referenced back to this object, so it'll produce a different thing. Freeform will flow it along the outside, and road light will do the same, but if you're doing a circular formation like this, freeform will work the best. So if we click OK, we're kind of left with all these, and it doesn't often work perfectly, and it never will, but because so I just changed that to 60 because it was close, and it seems like that arrayed everything pretty well. So the next step is to create this surface, and we're going to use the loft command. So the next thing we have to do is make a continuous curve that we're going to loft. So if we select all of these objects and use the trim command, there's no real way to make this easier, but okay, so I'm going to select that outside and make sure that's only selected, then type join, and we'll have this as a closed curve, and this is our reference one. And so if we look at these ones again, we can see that the bottom is a bit thicker than the top. So what we want to do is copy these set of curves down, and then we're going to scale them so they're slightly bigger to kind of match what this looks like. So we can use the copy command and copy these down. And we want to use the scale command, so that'll scale everything equally and scale it from the center point and just make it a little bit bigger. So the two ways to make this are either to use the reference curves at the top to loft or to extrude it down, but since these are two separate sizes now, we can use the loft command to match these to each other. And to do the same thing for the inner curves. And so now we have this surface on the outside, which is starting to look familiar. So on the top, to close these two ones, we want to use a command that's called planar surface, and that's going to make a surface between these two planar curves. And we'll do the same down here, so when we boolean them together later, it'll be easier for us. So now we kind of have this object, and that looks pretty good. So the next thing to do is kind of make this bowl at the bottom. None of my pictures kind of give the perfect angle, so we're kind of just going to use this one as a reference with the interpolate curve command. And I'm holding shift when I do this so it doesn't go on orthographic. Okay, so I'm going to hide these for now because we kind of have all the curves that we need. Let me just change the color. Actually, so it says here that I'm actually working on the wrong layer right now. So what I want to do is I have everything else hidden. So I want to select all my curves right now and move those to my vase curve layer. And I want to select all my surfaces and move those to my vase surface layers. So now everything's on the right layer. So if we look at this now, what I'm left with is this curve here is a representation of the bottom, and I have these surfaces that are a representation of the top. So if I move this one onto this line, and so if we're going to use the rail revolve tool, I just need one more line to make the bottom surface solid, so I can use the line command. To draw a line through this object. And if I look in the top, I can see that my object is not lined up to the middle of these curves. So what I want to do is move these to, sorry, I'll hide this for a sec, and move this object to the middle of this curve, or the quad of that curve. And so that makes sure that it's right in the middle. And what I want to do now is to, what have I done? So I'm going to hide this as well. And I want to draw a line. So this will help us with the Boolean operation later. So I want to move these lines so they're touching the quad of this line for rail revolve. Okay, so this is the profile of the base of my vase. So if I join this together, I'm left with one open curve. And what I want to do is offset this so there's a thickness to it when we finalize it. And we're just going to join this line. So now if we use the revolve command, we have this. So now we're left with this representation of this vase. And what we can do now is hopefully these align and we can Boolean these two together. But first, we can't Boolean them together because this is just a series of single surfaces. So what we want to do is select all these surfaces in this group. And join them together. And then we can Boolean union these together. So now we have this one solid object that is a representation of the vase that we have. So all these, and what we want to do is just move this to the surface layer here. So what all these kind of 3D and 2D commands that we've given you over the past couple of days hopefully will kind of allow you to make some objects for yourselves and try out all the tools and learn from there. So these are kind of the basics of the best ways of working and kind of the simplest tools in making 3D forms, and we're going to go over a lot more later, but for now this is kind of the best way to understand translating from 2D to 3D. So now, based on your project that that's due on Wednesday, we're going to learn how to make 2D images from your 3D work. So this will allow you to make drawings or to make diagrams. So just one thing I want to do is just move this vase I just made into the 3D scene so we can have that as another layer. So I'm going to use the move command and just move it off this bottom. So one thing I did when I finished modeling my room was I selected everything and moved it to the origin point. Moving it to the origin point is going to be really helpful when we move it to a different program like Illustrator because it'll be able to find it a lot easier. So this is going to kind of be the basis of what we're going to work with to make some 2D images. I don't know, do you want to talk about those different types of projects?
Yeah, sure. Do you want to open that?
Yeah.
Just put it in handouts, just in the main folder.
Yeah, so I just put this file in Dropbox that I actually made for one of the intro workshops when I was giving a short workshop on the basics of architectural drawing. And I mean, this is not something to be super worried about, but I think since we are showing you these different ways to make basically what we call axonometric and isometric and oblique projections, I thought it might be helpful for some of you to kind of understand this kind of systematic representation of different types of projection and really understand or be able to be deliberate why you want to use one over the other. And so, I mean, the two main things that we will talk about today is this set of projections. I mean, I assume that you guys are familiar with what we call multi-view drawings. which always show your depicted space or object from one view. So either it's a plan, so it's looking at it from above, or it's a section, so it's looking at it from the side, or an elevation. These drawings are basically have the same principle, even though in one case you're cutting through something, in the other you're just looking at it. On the other hand, um, what we call paraline drawings are actually belong to two different types of projections. So orthographic projection versus oblique projection, the difference is, and um, I'm just going to go over it quickly, but if you feel confused, I recommend looking this up online, or I can suggest you some books where it's explained. Basically, um, all these projection types, or the first two, orthographic and oblique, um, are representing reality by assuming that the kind of imaginary projection lines are parallel to each other, as opposed to a perspective projection where they converge in one, two, or three vanishing points. And and so the main difference between orthographic projection and oblique projection is that this sort of imaginary picture plane, that where we actually represent uh, our depicted object, whether that's perpendicular or so-called oblique, so at an angle to your um, object. And once again, this seems sort of something theoretical, but as you can see, there is a difference in, so this is the same simple set of blocks depicted. There is a difference in what you create, and in fact, what we call axonometric projections, which we more commonly refer to as isometric drawings, which, as you can see, is one type of axonometric drawing, is I mean, it's often used for technical diagrams, and in a way, and it's, if we go back to Rhino, the view that we are looking at in this space, you can see the label is parallel projection. So, I mean, isometric projection is a special type when x, y, z are at an even angle, so 120 degrees each. But basically, it's this, the idea is that you can rotate this object as you want, but you're looking at it in a way that I mean, it's abstract because we don't see things in reality like that, but it's still somewhat close to kind of a common sense idea, as opposed to what we are going to show you, an oblique projection that doesn't exist in a Rhino view, because in fact it's a kind of distorted view. So you have to skew your model to produce them, and in 2D drafting, it's in a way a bit easier because you just kind of draft over the drawing, but you take if you go back to this table. So if you really look at this object, it's actually, I mean, it's a three-dimensional representation as opposed to the plan, but basically it's taking that same drawing and kind of projecting the 3D dimension over it. And so these are the two that we are going to show you, as well as perspective, which I think is probably more self-explanatory, because like commonly we use that in renderings.
Okay, so if we're all working from this little house, was everyone able to get the file? It's not theirs.
It doesn't show up for me.
Okay. Oh yeah, it's not uploaded, so I'll put it in there. Actually, what I'm gonna do is just save this one slightly differently, and then I will. So hopefully everyone will be able to get that in a sec. Just gonna give it a couple seconds to upload. So if everyone could copy this out of their Dropbox folder rather than pulling it out of their Dropbox folder, then everyone will be able to use it. So there it is. Okay, so I have this model of this interior space with these two interior objects, and I've moved it so it's centered on 0, 0, 0, as you can see here by my grid line. So the first one, this is kind of just an overview one. I don't know if you're going to use it for this project, but the section command will allow you to make a section through all of this. So if we choose one that roughly cuts through the bottom of the window and make a section, then if we pull this away, we kind of have a representation of this section, and I mean, we have to fill in a bit more information to make this work, but that's kind of what drafting in 2D, but this will give you the same type of layout as you have for your perspective drawing, so everything will match. You just have to fill in the information with that, and in further classes we're going to kind of refine this and make it a bit, give you a bit more information, but for right now I think the best way is just, if you need to make a section, you can use the section command and then fill in any extra information that you need. So the next one we're going to look at is, if you right click on your one and go to isometric, or set view, and then choose isometric, so this is one type of projection we just talked about. And I think we're going to select southwest. So what you want to do is, this is where it gets a bit tricky. As soon as you set that view, you don't want to change this view necessarily, because you want these lines to always be the same. So be cognizant when you're moving, use the shift and the right mouse button to move around, and then only use the zoom to kind of reference in. One thing we want to do is just hide this roof plane right now, because it's going to mess up our file at first. So what you want to do is select this object without moving the orientation of the camera. Another thing you can do is, if you have this view that you want to use all the time, you can type in named views, and then this will allow you to create a view that you can always go back to. So if I save this as ISO southwest, if I move this around and I'm somewhere and I want to get back to it, I can just go back to this and it'll give me that exact same camera location. So the command that we're going to use to make a 2D representation of a 3D object is the make 2D command. So you can just type in make 2D. The thing you want to make sure is you have everything selected here that you're going to use, and you have the viewport highlighted that you want to make the drawing from.
And also, you probably don't want to select things that aren't visible or you don't want to use, because potentially it's just going to drag down the processing power of your computer.
So we kind of come with this 2D drawing output command window. So you have a few different options. What we want to do is use the current view. The current C-plane will give us a top view, which we don't want. And then these are kind of more for product design. So this will give you all 4 of your viewports arranged. So those are those 2. And then you have options. So the first one is show tangent lines, and those will help you show different parts of your model. Tangent lines is just going to make your modeling life, or your 2D modeling life, a little bit too hard, so don't have that one highlighted. Your next options are show hidden lines, so that will show you kind of the back edges of all your objects. So if you're trying to show the depth of an object, or if you're trying to show that it maybe changes shape, like the object isn't the same all the way around, this option might be nice. So for now, we're going to keep it highlighted because we can always hide those layers. And then the next option is this maintain source layer. So this one's really important because we've spent all this time making sure that we have each one of these objects in specific layers, so we can easily reference those for line weighting. And what we're going to do for this class at least is just export everything into Illustrator and line weight from there, just as kind of a first. I think everyone's probably familiar with that, so that'll be an easy way for everyone to do that. And so then it kind of just gives us these layers that we want to do. So what you want to do is just rename this one so it makes sense. So ISO Southwest, and then it's going to make these three as sub layers within that layer that we'll be able to access. So if you click OK, and depending on how fast your computer is, this can take anywhere from 2 seconds to 48 hours, depending on how complicated your project's getting. So it's kind of just knowing your computer and how complicated. So these are all straight lines, and I had the hidden lines command on, so it has to figure out all the intersections of all the lines and compute which ones are going to show, how they're going to show, which layer they're on. So if I took off hidden lines, it would be a lot less complicated. The other thing is that if you start to have curved surfaces and lots of intersections, that's where it has to make a ton of decisions. And right now, it only runs off a single core off your computer. It's something they're changing in Rhino 6, so it goes really slowly. So for now, you guys should be okay. But if it's taking a couple of minutes and you have a bit more complicated geometry, just let it work, have a coffee or something, and come back.
Yeah, and honestly, I want to say that I find even the Mac version of Rhino, compared to other software that you would think it has crashed, it actually, for me, usually works away for a while and then does the job.
Yeah.
So sometimes even when it seems like it's hopeless, it's worth waiting a bit and just doing something else.
Yeah, there's been lots of like 24 to 30 hour make 2Ds, so don't feel alarmed if it takes 10 or 15 minutes to kind of figure it out. If you have lots of lines and lots of objects that it's trying to figure out. If you have a paid version, you can get a beta version of Rhino 6 and it's a lot faster. We can go over that for anyone after class if you want to get Rhino 6 and you have a paid version. So what it did was it made this representation of my space and it put it right over top of this other object, which is going to make modeling a bit hard. So when you first do it, it leaves it all highlighted. So you simply just want to move it over a little bit. And then over here, this is my, this right here is where it started. So all these are different layers that it kind of computed and we can use to make our drawing. So what I'm going to do is just highlight this layer and turn off all these layers so it's easier to work. So if I open up my top viewport, now I have these objects, and you can see all these white lines in here are all the hidden lines, and usually we could use those as depending on which depth you wanted to show. So maybe you wanted to show the depth or the assembly of this window or how the stool was put together. We can put those in as dashed lines, as you know from Design Media 1 in Rhino or in Illustrator. But right now, this is all looking really complicated, so I can turn these off and on, and you can kind of see the difference in complication. And then as well, we can look at just turning some of them off because we put everything on layers. So it's nice because we can kind of figure out exactly which ones we want. And maybe what we want to do is only show the hidden lines of the picture frame. So that'll kind of narrow our focus for today. Simplify everything. So down here you can see I kind of messed up, and so what happened is you can see that this stool, because it's a curved surface, they kind of appear like this, but it'd probably be nice if there was this extra line here. And this is where, when you make 2D, you want to spend a little bit of time beforehand in Rhino really looking at your drawing, because it's a lot easier to draw lines in and put in extra information now than trying to do it in Illustrator, which isn't really precise. And I know lots of people draw and work in Illustrator just because it seems easier, but the precision that's afforded in Rhino will really help you in the end. So if you just think about your workflow, it's easier just to kind of make this 2D drawing and see what's going on. So this problem here is that in my model I didn't make sure that this object was sitting fully on top of this. So this vase is actually inside this stool right now, so that's why this bottom line is hidden and it's not projected correctly. So you can see over here, if things are sitting correctly, all the lines will appear. But because here I didn't line up the vase correctly, there's a mistake. So there's two options. One is you can go back into my drawing and fix it, or the other one is you can draw a line across the bottom. No, never mind. So what you can do is just delete all these layers. So I want to turn everything back on. So you can see the problem here. This is the top of my stool, and this is my vase. So it's sitting right inside. So what you want to do is use the move command and snap it to something on top of this stool, and then move it into place how we had it. So now it should work properly. And I want to turn off all the curves. So if you have these curves selected, sometimes it's going to, if you have these curves on, sometimes it'll make 2D and it'll draw these curves for you, which you don't want, especially if they're reference curves or something. So it's always best to have your layers and turn these off, just so they don't show up. Someone else sent me an email asking about why would you keep a curve if you have already used to extrude it. Kind of a best practice is to keep all your curves that you use to make all your objects. So if your object is slightly wrong or the measurement is off, you can delete that whole surface and turn back on your curves layer and find how you originally made that object and then remake it from there rather than trying to figure out where you went wrong. So you can always go back to your curves layer as a basis for everything that you've drawn. As a kind of fail-safe, if your objects aren't quite lining up or your surface isn't quite right, you can rework from where you were. So in the last one, we did the isometric projection. So now we're going to use an oblique projection to make this. So this is a little bit more complicated, but I've provided everything you need in the Dropbox folder. So in the Dropbox folder, there's this text file, and this is just a little macro command that we're going to use in Rhino to make our oblique projection. So what you need to do is just open it and copy these contents. And so what you need to have is your, So the best practice for this is to highlight what you want to make into an oblique and copy it and just move it into a different, slightly away, and then hide everything else just so it'll be a bit easier. So now we have this, and we have our top viewport, and I have this file here. So what it does is it selects the top viewport, and it rotates in the top viewport our object 30 degrees. Then it selects the right viewport, and from the bottom corner of a bounding box, it's going to shear our object 45 degrees, and then it's going to just zoom out and allow you to see that object. So what it does is in our top viewport, it's going to make our object appear like it's an oblique projection. So if we copy this, and in Rhino, you type macro, and macro editor is going to pop up. So this is a little editor you can use, and what I mainly use it for is different projection types. So what it wants is, now that this is in our macro editor, what you do is you highlight in the top viewport what you want it to create, and then you click run. And it's going to run this script for us, and we're left with this oblique projection in the top viewport. So what it does is it actually shifts our entire 3D object. So that's why it's always good to copy this object when you're going to do this, or else if you go too far and you're left with this 3D object rather than the one you created, it's going to be a real pain in the ass, and you're going to have to delete everything and use your curves layer. Hopefully everyone uses the curves right to rebuild it. So in your top viewport now, you have this oblique projection of the space, and we can use the make 2D command again. And what I'm going to do is I'm going to turn off hidden lines to show you, and it'll just be a bit faster. So if I click OK now, maybe. And so I know from experience that the most complicated thing right now is that vase I just put in. So that's what's making it take a little bit more time to think. But I mean, that was like 30 seconds, so it's not that big of a deal. And I'm just going to hide this for now and take a look at what we have. So what we have, you can see here the bottom of this looks good. The stool looks pretty good. The only thing is you can't really understand the depth of the stool right now. Like here with all these lines, it's easy to understand the depth of the window and how they look. But this stool kind of just looks a bit weird, and that's because it's all rounded edges. So Rhino has a bit of a tough time trying to understand rounded edges in depth, especially if you're trying to make a simple projection type of that, then the rounded edges aren't always going to show so easily. So what you can do is you can kind of look at this object, and you can see that this is the top layer, and then it goes down this side, and then this is the bottom layer. So maybe the easiest way to fix this is just to copy this line is to just find out how long this piece is, which is 22.5 millimeters, and offset this. So if we offset this 22 millimeters, it's not going to work. How did I do this last night? So we just want to copy this up so it looks, so it gives it a bit of depth, and then you can see that there's a bit of depth to the stool, and it'll look a bit more believable in this perspective. So that's just a simple way to kind of add another line on to show the depth of the stool. And I mean, everything else, we've spent time making sure that everything was a solid, everything was joined, and everything was in together, and also placed on each object properly. So everything looks good. So if we're looking around, maybe the last thing we can see is that this line right here doesn't really make sense. So we can just delete it, and you can understand that this is sitting a bit back. And then we also have this extra line here, so we can just delete these and it'll be a bit cleaner. So now we have this kind of oblique projection, and another.
Yeah, you can show that.
Yeah.
But actually, I just want to mention something. So, just want you to look at the macro that we use to create this projection, and I mean, I guess just so that you understand that, of course, like in isometric view, we are able to rotate our object. So to make a simple straight up make to the isometric drawing, we can rotate our model at any angle. So you get the view you want. And similarly, to produce these drawings, you can, of course, project your vertical information in any direction you want. And so one, or I guess two ways to do it is, on one hand, you can rotate your initial model before applying the same command. Or so here, when in the third line it says rotate 30 degrees, that actually produces the 30-degree angle of this plan. So we are still, I hope you understand, we are still looking at this room with the plan of it undistorted. So that angle down in the corner is 90 degrees, like it's in the original model. And so if you run this macro again, and let's say put 60 degrees, it's going to, and that might be worth just showing so we see the difference. So it's going to produce a different view of the same room.
So this is this room here. You want to do 60?
Yeah, sure.
So
so you can see that now we are sort of yeah, basically we rotated it 30 degrees further. So we see the window more and we see the door less, to put it simply. So I recommend that depending on what you want to do, to play around with these angles. So it's definitely not just one straight up view that that would be the only one to get.
there's another interesting one too. This is kind of similar to those iceberg ones you showed, where you limit this. And it kind of gives you like a real, like a vertical slice of the room. And this is good, maybe not for the room, but if you're trying to show the verticality of a building, but also a side, you can use a macro similar to this to kind of represent something else.
I mean, you could actually leave it at 0 and then it just shears it straight up.
So are you typing in run share keys, or in the first few steps you use the load?
Yeah.
So you're just sort of doing it
So the macros here, it's in the Dropbox already.
Yeah, that's clear. This is how you load it.
So we went over, you type in Rhino, you type macro editor, and then enter, and you'll show up with this, and you just need to paste that into here. So paste this file into here, and then from there you can change the rotate and the shear command to kind of create these different types of parallel projected drawings.
But in fact, if you know you just want to take that command straight up, you can just paste that text into the command line and press enter, and it's going to do all those steps. I like this one because you can actually see what you're doing more clearly in Rhino.
So now I know everyone here's probably had spent time in Illustrator. So there's kind of two different ways to get this into Illustrator. One is just to highlight. There's two things. We want this to go into Illustrator, and the easiest way is to hide everything else we have right now, just for a sec. And we want to move this to 0, 0, 0, because when we export it and open it up in Illustrator, we want it in the middle of the artboard already. And so putting it at 0, 0, 0 is going to put it in the middle of the artboard for us. So there's two ways to do this. One way, you can select this and click export selected, and then if I'm exporting it to my desktop, I can go here and click Illustrator and give it a name and click Save. And so this export option comes up, and what you want is you always, if you're doing a diagram or you know the size already or the size doesn't matter, you can just use snapshot and it'll just make this object fit onto your artboard, and then you can size it however you want. But if you're trying to make scale drawings, you need to make sure that you keep a model scale that you know and you can translate. Here is kind of where it asks you to do that. So the easiest way to do it is just to say that you want 200 to 1, so you can type 200 to 1 in that, or you want 100 to 1. So you can just read it that easily, and then it'll automatically do that for you.
So what this means is 100 millimeters in your model, which is 1 to 1, will be 1 millimeter in Illustrator, which is a 2D scaled drawing on a specific size sheet of paper, basically. So like this is 1 to 100, just sort of written the opposite way.
Yeah. So 1 to 100 will probably work just fine for this purpose on 11 by 17, because that's for that one. So we click OK, and then you'll see here that it says file successfully written. So here we can just click open and open this. And so what happened was this object isn't really in the center of my paper, but it's at 1 to 1, so hopefully everyone knows moving things around. So this is the first way, and what it imports, all of these are on a different layer here, so you can easily kind of give those different line weights and switch that around. I'm not really going to go too much into that, but just know when you bring everything in, it gives everything a 1-point line weight, so everything looks super heavy. So it's just to start, maybe easy just to give everything a little bit of a lighter line weight, and then work up from there. So what I like to do is set everything to the minimum if I'm working like this, and then I can just go through my layers and start to highlight the main things that I want to highlight. So there's one more way of kind of exporting to Illustrator, and that's actually to make a simulated paper space right here. So I find this easy if I'm laying out diagrams or anything. It's easy just to work right in the paper space and then bring it in. We're going to cover layout in a different class, but this is just kind of a quick and easy way to mock things up in your actual Rhino and then work from there. So if we make a piece of paper that's 17 inches by 11 inches, we make a piece of paper that's 17 inches by 11 inches. We're left with this, and we have this big thing here. So what we're going to do is copy it, and if you have a simple object like this, it's always good to kind of leave fragments of your model